Hi, welcome to our video on linear relationships form. I'm taking a look at our toolkit first to make sure your notes are all up to date. We're going to look at two different toolkit entries here so that you can use both of them, and you can also make sure you have all your notes for both of them. First one here is representations of a pattern. This is found on page 37 for me. I know that says 36, that's the page before. This is page 37 in mine. If you have a newer toolkit, it's actually a little bit earlier, but you can use your index and look for representations of a pattern. In the standard linear relationships form, we're looking at giving you one of these linear relationship forms. Often you'll be seeing a graph or a table or a rule, and then you're seeing a situation. Now, sometimes that situation is a tile pattern, but sometimes not. Sometimes it's a word problem, other things, but either way, it's a linear relationship. And all linear relationships have two things that you're looking for to be able to write the equation and really transfer that information from one form to another form. Those two pieces come in the side of our rule. Our rule is the format y equals mx plus b, known as our slope-intercept form of a line. And I'm actually going to jump down to another toolkit entry before coming back to this one, because this one will make sense after you have the next toolkit entry. So follow with me here as we go to look at the next one. This toolkit entry here was used for comparing functions as well, and it's called linear equations because it focuses on how we can write our linear equations given that it's the slope-intercept form. Slope-intercept form, all right, gives us two pieces of information, m, which is my slope, and b, which is my y-intercept, also known as my starting point, the initial value, the value of y when x is 0. Slope is also referred to as rate of change in y over change in x, and can be found using this formula if you're given 2 points. So as we look at this, we can see a table here. There's some examples of tables and how to convert, or not to convert, but to define the information inside of this table, finding our slope as our change in y over change in x, all right, finding those two pieces, and then being able to write the equation from it. If you want an explanation on this toolkit entry more and all the details of it, go back and watch the compare functions because I go through all of that. Feel free to pause the video if you don't have these notes down and then write them down. Sliding down now to graphs, and you can pause the video here. Again, this is how you read from the graph, and I went in detail on this piece of it in the video compare functions. Go watch that video if you want more information on it. Pause it if you need these, but I want to make sure you have these before I move on to the other one. All right, now I'm assuming that you've got all this. I'm moving on to the next one. So coming back now to this toolkit entry, now we can see how we can use the information we just saw about the slope-intercept form of a line, y equals mx plus b, to identify two things, my slope or my growth rate and my y-intercept. Those are the two things, and if you can identify those in any of the forms given, you're good to go. I'm going to start off with our tile pattern. Tile pattern, the amount that it is increasing every single time is my slope. Now, usually you're like, but wait a second, the slope is typically the change in y over the change in x. It's normally a fraction. Well, it is. We're going up 2 tiles, so up 2, over one figure because we're going from 0 to 1 every single time. So my change in x is over 1. And 2 over 1 just reduces to 2. And that's why my slope here is 2. All right, and we can see that in my equation here. I put 2x. Now, my number of tiles in figure 0, I can simply find that. That's right here. Figure 0 has 3 tiles. Positive 3 tiles, and that's why my equation has a positive 3. If you can identify those two pieces, you're good. All right, so let's take a look at some of our other situations here. I'm going over to my graph now. Let me just clear some of this up. All right. Now in my graph, I'm going to identify my slope by picking any 2 points. I pick points that are on the grid line so where I can read the whole number coordinates. And I notice here I'm going up 2 over 1, up 2 over 1, up 2 over 1. So my slope is up 2 over 1. In other words, 2. That's again why we put the 2 in front of x. And I look at my y-intercept. Where is it crossing my y-axis there? It's actually at 3. In other words, 3 tiles. And that's why 3 is the constant in my equation. Again, those two pieces come from my tile pattern. They come from my graph. And now let's see them in my table. So my table down below here, All right, I can notice again the change in y every single time is going up 2. The change in x here is going up 1. And my slope is always my change in y up 2 over my change in x, 1. And up 2 over 1, as we've seen several times already, is 2, and that's exactly why it's right there in my equation. Looking at where x is 0, the x value here being 0 tells me my y-intercept, and I see that it started with 3 tiles. That's my initial value. So once again, I get the plus 3. So if you have those pieces, you can get to that rule anytime. Once you have that rule, the rest of it can come straight from that rule. If you have this rule, you can graph it. All right? I like to graph it. There are some shortcuts, but I like to just plug it into a table sometimes. And you can pick the y value. You can pick the values of x, 0, 1, 2. You can pick -2, 0, 2. Those are all good values for you to pick. You can pick whichever ones you want. Plug in the x value. So in this case, I'll take this -2 here and plug it in. Y equals 2 times -2 plus 3. All right, that gives me -4 plus 3. And I see that y equals -1. And that would go in here, giving me a coordinate -2, -1. I can plot that point on my graph and go from there. So that's how you can move from one piece to another. If you can get that rule, you can get a table. You can get a table. You can plot your points, connect the line, and so on. It doesn't matter which order you go in, as long as you can get between them. Let's take a look at some examples now from Study Island. This is our first Study Island example. They give us a situation that's not a tile pattern. They give us a word problem here. But again, we're going to be looking for two things. We're looking for that rate of change, otherwise known as our slope, and we're looking for our starting point, otherwise known as our y-intercept. Okay, so those are the two parts we're looking for. Let's examine that as we read. Matthew rented a car. The rental company charges a one-time fee of $75. One-time fee. That sounds like an initial fee or a starting point. Good. Plus an additional $30 per day. Per. That right there tells you it's a rate. $30 per day. Write an equation to represent this situation where x represents the number of days he rents the car and y represents the total cost. So we would come across this and we'd say the total cost is $30 per day plus a one-time fee of $75, giving me a rate of 30 and an initial fee or starting point or y-intercept of $75. That's how I get to my equation from there. From there, you could then make a table and a graph, whatever else they're asking you to do, but get into the equations, probably the most important part. Let's take a look at another example. All right, example 2 here says, another word problem here. A concession stand has 250 bags of peanuts when it opened. Each hour, the concession stand sold 50 bags of peanuts, right? An equation that represents the situation where y represents the number of bags of peanuts in the concession stand. The concession stand has after X hours. Well, it had a starting point of 250 bags. So B here in this case is 250. And then it's a rate. Each hour they sold 50. That means they're losing 50 every single time. So that's my slope in this case. Give me an equation of y equals, or the number of bags left is losing 50 every hour plus we started with 250. Now, the way they wrote it down here is not wrong, and it actually makes a little bit more sense to say, hey, we have 250 bags and we're losing 50 every hour. It makes sense to write it that way, but that's not technically slope-intercept form. I'm okay if you write it that way just to get it into an equation here, but if they are specifically asking for slope-intercept form, this is the way it should be written. Let's take a look at a few other examples. Here's an example of a graph that we're looking at. Sam mows his neighbor's lawns. The graph represents the number of lawns Sam can mow given the number of hours. What does the slope represent? All right, well, in this case here, let's start by calculating the slope. I want to get the full equation here. Calculate the slope, pick any 2 points. You could pick 0, 0, which I really like, or you could pick either the 2 points they gave. So I'm going to go from 0, 0, and I'm going to go up and over to my first point. How much up did I go? I went up 2 and over 1. So therefore, my slope is going to be up 2 over 1. All right? So now at that point, we have our slope. Now we need our y-intercept. Our y-intercept is 0 at this point, so B is 0, which would give me an equation of y equals 2x. I wouldn't need to write 2 over 1. It does reduce to 2. All right, and then I'm adding 0 at the end there, so it just gives me the equation y equals 2x. At that point, you could then move into a table or anything else that you needed to. All right, let's take a look at one more example. We'll go to a tile pattern for our last example. All right, let's take a look at this example here, 3-1A, this tile pattern. First off, I'm going to just check to see how it's increasing from one figure to the next here. All right, so in this case here, I notice if I take a look, I'm noticing I'm adding 1 here on the tail, all right, because I had 3 and now I only have 1 there. I had 4 across the bottom here, and now I have 2 extra ones there, so I'm adding 2. So I've got 1 here, 2 here, and I only had 2 coming off the top, and now I have 3 coming off the top, so 1 there. So it looks like I added a total of 4. Let's check to make sure that it's still increasing that same amount going over here. I'm adding 1 there again, I'm adding another 2 there, and I'm adding another 1 to the top, so it looks like I am adding 4 every time. That means my slope is going to be 4, and therefore I'm going to start off with the equation y equals 4x. Now, this was in figure 2, and I had 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 tiles in figure 2. If I'm adding 4 every single time, that means that figure 1 would have had, if I go backwards, figure 1 would have had 5 tiles, and figure 0, if I go backwards, would have had 1 tile. That way I'm increasing by 4 every single time. 1 plus 4 is 5, 5 plus 4 is 9, and so on. So that means figure 0 had 1 tile, so my rule is going to be plus 1. That's how I get to my rule here. Let's actually do one more example. I saw a good table here in the closure problems that we want to check out. Taking a look at 3-118, Chapter 3, Problem 118. We see a table here, and they give us a few different values. It's kind of like a silent board game. All right, and again, I'm going to go from here to find my rule, and then I can plug in to find all the missing values that I'm looking for. To find my rule, I can pick any 2 points that I want. I'm going to pick from here to here, from 0 to 1. Because from 0 to 1, it's just going up 1, which makes it really, really nice for me to deal with. And then going from 5 to 3, I'm going down 2. That means my slope is going to be down 2 over 1, which reduces to -2. If you picked any 2 points, it would have done the exact same thing. Going from -6 to 10, I'm going up 16. All right, going from 17 to -15 there, I'm going down 32. So down 32 over 16 reduces to -2. I see I get the same thing either way. So I know my slope here is -2, so it's going to be y equals -2x to start. Where's my y-intercept? Well, that's when x equals 0, so that is 5 in this case. It's a positive 5, so it's plus 5. Now we can use that rule to go ahead and figure out all the other missing pieces here. All right, you can just take each of the x values that they give you and plug it into our rule to find the missing y value. So I'm going to start off here with -10. So y equals -2 times -10 plus 5. And 2 times -10 is going to give me a positive 20 plus 5 is going to be 25. So I put 25 in for y. You can do that for all of these. I can come back and I can just erase that -10 at this point. All right, and I can replace it with the next x value, which is 5 here. 2 times -5 is going to be -10 plus 5 is going to give me -5. I can put -5 in there. And we can keep going with all of these to get the different pieces that you're looking for. And go ahead and pause the video, see if you can't figure it out on your own, and then come back and check your answers. Well, if you're coming back and checking your answers now, let's just check. We should have -11 there. You should have had +7 there. And you should have had -7 there. So double check your table. Hopefully you got those all right. And I hope this helps. Good luck.